Okay, we'll go ahead and get started here. Let me share screen. Okay, do you all see my screen? Is it in presentation mode?
Yes, I do.
Okay, and when I go back to the lobby, I don't lose that. Ambush, can you admit people as they come in to the Teams thing? Thank you. Okay, well, let's go ahead and get started. Thank you all for coming. It's a good evening or afternoon to you, or good morning to you, depending on where in the world you are. So today we're going to talk a little bit about Brick and the consortium and a little bit about this kickoff. And then we're going to double click into Brick to have a little bit more of a detailed discussion on Brick, in particular, and how it works under the hood and how it is that we actually build Brick and create it as a software project. And that will lead us into the Brick working groups, how after we see how the software is constructed, we'll go into how we are going to organize around creating future versions of Brick. And then from that, we'll transition to a little bit more about the Brick Consortium again, and then the Brick roadmap and where we're going and what we see the next year and beyond to look like. So we're planning for about an hour 10 of content, and then to have some time to discuss afterwards. So, you know, it could be done in an hour 15, hour 30, somewhere in there. We will see how it goes. If everyone's got all the questions answered, we'll wrap up. If we're having a great discussion, we'll keep going. So with that in mind, just a reminder, we are recording this, so just be aware, and if you could all mute yourselves, that would be helpful. So we'll have plenty of time for discussion at the end and questions at the end, but we'll stop every now and then if anyone's got any burning questions. You can put things into the chat too, and we can address it kind of on the side, or stop the presentation and have a discussion if there's something really burning. So, okay. I'm hoping I don't have to spend a lot of time explaining what Brick is. I think if you're here, you probably have a sense of that, but let me do it at a quick top level. Of course, just to remind everyone, the Brick schema, it's a uniform metadata to define how the building data is modeled, and it's meant to model the logical, physical, and virtual entities of the built environment and the relationships between them. Brick's focuses on interoperability. The core tenet of Brick is that this building data existed, but it was all in different silos, and so it was hard to work together. And so Brick is all about how do we bring the data out of these different silos and make them interoperate together. But it's not about replacing other specialized standards. Brick has some information about the location data and how things are spatially related to each other, but Brick is not trying to replace IFC. Brick has information about how an enterprise resource management system or a computerized maintenance system would work, but Brick isn't trying to replace Maximo or Dynamics 365, and Brick isn't trying to replace the building automation system, but it is trying to expose the data of those systems to make them possible to for other applications to work with those subsystems. Brick is an open source project. All the development happens out on GitHub, and we'll talk more about that soon. And Brick was initiated from researchers from the academic community of a number of universities in the US and Europe and IBM Research, Brick's about 5 years old now, and so it's starting to come into its own. So that's for a quick introduction to Brick. What does Brick do? So what industry-wide customer problems is Brick trying to solve? And the first two bullets here are sort of two sides of the same coin. So Brick allows the owner of the built environment to really own the data. And what I mean by that is that sure, they they technically own the license to the building automation system, and they have configured all the data in it, but that data may not be very useful to them without some extra help. It's like if you've ever had any graphic work done, if someone gives you the result as a PNG or a JPEG file, that's really hard to edit and work with. What you really want is the Adobe Illustrator of your logo, so you can go in and tweak it and make those changes with a high quality fidelity and have that data really be useful instead of sort of locked together. So the Brick helps building owners and building managers own the data about their built environment. And the same token with that empowers the customer to take their data and be able to integrate best-in-class applications. So be able to make that data useful for be able to make that data useful to other applications and implementations and have a data set that they can reuse. Of course, it's also designed similarly, just like it allows the owner to go out and be able to integrate to different applications. We want to have Brick enables third-party applications to be able to come in and talk to these different data silos. So it's a way for application developers to write tools and applications and analytics that can interact with a building without having to do a lot of rework in onboarding configuration every time they come to a new building. And it provides a spot, and we say platform, but it's a little more virtual than that, a way to integrate the data from these different systems. So it is a virtual space where the data from different systems can be integrated together into one overarching system that plugs between all these different systems. And in the ideal world, it's going to allow for plug and play between different equipment and manufacturers, even if they're from different providers. So we have a way to describe the data about our applications, about our equipment, about our systems in a consistent way, so we can have easier integration. So I'm going to tell a story here about Brick and how we develop it and how we get to the consortium, but I'm going to use it in the context of the Brick release. First off, if you don't know, we did a Brick 1.2.0 release on February 20th, so congratulations to all the people who worked on that. In Brick, the main artifact is the schema that we create in RDF, and we serialize out into this turtle file. It's the brick.ttl. That's the golden master. That's the, if we were shipping software, that's what we would burn onto the CD-ROM and put in the envelopes and ship out. When you say you want to download Brick and get Brick, this is what we're talking about. This TTL file that defines the schema. Brick is a typical open source project. It's hosted on GitHub, has a BSD license. The way things work is the community has a mailing list that it discusses problems and issues. Sometimes those lead to GitHub issues, or sometimes we create things right in GitHub issues. People create pull requests with changes. Sometimes they're from developers, sometimes they're from third parties, and then we go out and release software through the appropriate channels. So the Python packages go out to PyP, the turtle file goes on the website, and so on. Brick 1.2 had a lot of contributors, and this goes beyond just what GitHub recorded as people who made check-ins or commits. A lot of the contributions to Brick 1.2 came from people from the mailing list or opening issues with suggestions of new classes to add or what have you, and that those folks vastly outnumbered the developers, and so we thank every one of them for making Brick better. And Brick development, by and large, is going to continue to work like this. Even in the consortium, it will still be an open source project developed through GitHub. We'll talk a little bit about when we get there about what's going to change, but it's not much. But besides Brick 1.2, there's other things that we released. There's tools, there's data sets, there's best practices. Those are all also things that the Brick project has been creating. So Brick 1.2 was great. And we're looking forward to 1.3 and beyond, but we do want to think about some things going forward. So first, how do we make sure that we're growing the ecosystem and solving actual industry problems? How do we make sure that this plugs in to all the right places that we need? How do we make sure that it has that it's solving the problems that people actually have and is getting to the right places and is actually being delivered to folks. Standards exist over decades. BACnet is 25 years old. Brick is 5 years old. How do we think about Brick in the sort of decades time span, not just what are we going to do in the next couple of months? And then finally, how does the community fairly govern a standard? Brick 1.2.0 came out when the Brick developers kind of looked around and said, no, I think this is done. But if it's going to be a standard that everyone is going to invest in and make a commitment to, how do we make sure that everyone has a voice to say when it's ready to go? And so not surprisingly, some of the things that we're thinking about to answer this is the Brick Consortium. And I apologize, this is kind of a wall text. But let me just work through it a little bit. This is kind of the from newspapers, the who, what, where, why, and when, the 5 W's of Brick, the consortium. And so the Brick Consortium, it's right off our IRS paperwork. It's a nonprofit membership corporation whose purpose is to encourage the research and development of the Brick schema specification for the Brick environment and supporting tool documentation and best practices to promote Brick. And so the consortium's main mission is to develop the Brick schema specification. It's an open source project with member participation. And the consortium is made up of organizations from researchers, technology providers, and building operators. And it's meant to serve as the organization that can give the long-term governance and support to Brick to get it out to the 25-year mark. So how do we get to 2040, which is both seems a long way away and actually isn't that far away in 2040 and of course beyond. So the consortium, it provides the governance for the standard, it provides a home for the development, and it provides a home for some of the ancillary things that the schema needs to support. Conformance testing and the process for that, a set of tooling around the Brick schema, and repositories of reference models, sample data sets, canonical use cases, things that you would need to support Brick as a developer or as an implementer or as an RFP responder. Where can we have material to help you successfully use Brick in your project? The consortium also is going to fund some of the research work around the Brick schema in universities, and as well as fund some of the evangelization and marketing around Brick and bringing Brick to the marketplace and having a presence at things like the AHR show or maybe a RealCom or host an event itself or something, but to have some have the capacity to function on its own and to work as a collaborative group to promote and help Brick spread. We'll talk more about membership down the road, but just as a preview here, membership in the consortium, it's open to commercial entities, it's open to universities and nonprofits, and it's open to individual academic researchers. For commercial entities, there's 2 classes of membership, and we'll talk about that later. And we'll come back to this. The universities and nonprofits don't pay any membership fees. If The individual researchers are meant to join in cases where the institutional barriers might be too hard to join that, but we still want individual researchers still want to participate. And I want to reiterate that membership is not required to participate in the open source development effort. The Brick has been developed as an open source project. It will continue to be developed as an open source project, and you don't have to be a consortium member to do this, but if you are a consortium member, you're both supporting Brick and you have more of a say in the governance of Brick and when the scheme is going to go out. So we'll come back to all this a little bit later. I think actually I've talked about most of this. So the consortium, I guess I've covered this pretty well. We'll talk about the working groups, which are the evolution of the Brick mailing list and the Brick developers, and a little bit more of a structure to bring people in and to focus development in a couple of different areas. And this is all overseen by a technical committee that's going to be elected by the membership. So with that, let's just talk a little bit more about where we're going for the rest of this discussion. I'm going to hand the meat of the conversation over to Gabe Fierro, who's finished his PhD at UC Berkeley. He is a much better presenter than I am, and you will have a much better time with him. But he's going to talk about Brick and the nuts and bolts of Brick and how we develop it. And then I'll pick it back up and I'll talk about the working group and the structure of the organization, and then we'll turn it over to the Brick roadmap, which we hope will be more of a discussion. And so we'll love to hear from you about what you want to see in Brick, what you're looking to support in Brick, and we want to talk about where do we see Brick going and how do we move the industry forward. And so with that, I'm going to stop sharing my screen and I'm going to turn it over to Gabe.
All right. All right, you can see my screen okay?
I can, yes.
Okay, wonderful. All right, hi everyone. My name is Gabe Fierro. I'm finishing up my PhD in computer science at UC Berkeley, and I have been pretty active on the Brick GitHub. So if you've interacted with Brick, you've probably interacted with me in some form. And so I'm going to give you a quick sort of overview and refresher on what's contained within Brick, what's there, and a couple examples of how that's used, how it's defined, and then later on we'll sort of dig into how we might extend Brick, how that development process might go forward. So if you're here in this call, you're probably going to, you recognize that working with data in buildings is very hard. And the reason why it's hard is because there's no consistent machine readable representation of the data sources that come out of the building, not just limited to the building management system, but the meters, any sort of aftermarket add-ons, installed sensors, and the context of those data sources. And the solution to this is some sort of semantic metadata, the data about the data that describes the data sources, that tells us what they are, where they are, what they're doing, where that data came from, how that data relates to how that building is operating. And the reason why we needed something like Brick is because when you go into your building today, you're going to be presented with some screen like this, pulled, from the freshest install of Internet Explorer 6. And this is, your BMS, the OS for your building. And it's these sorts of points, the sources of cyber-physical data that we want to be able to pull out, we want to be able to contextualize, and essentially make that data easier to use, easier to access, easier to leverage for your models, your fault detection, your controls, whatever it is that you need to do with your building data. And the way that these points are typically described today is, with these sort of ad hoc labeling and naming schemes that, some engineer had to go and put together when the building was commissioned. And there's really no, rhyme or reason or standard for how these labels are put together. And so what Brick aims to do is bring regularity to this, bring structure to this, and allow the contextualization of these data sources beyond just a simple human readable label, and actually produce something that can be understood by a machine, that can be checked, can be verified, and can be incorporated into tools without having to worry about what that naming scheme was to begin with. And so the challenge that we're trying to solve with Brick is essentially how to get data out of those data silos, or how do we get it out of the PNG or the JPEG, as Eric put it. And so what's important here is that we want to, as much as possible, leverage other existing metadata standards about the building. IFC and GBXML and Revit and these Kobe and VBIS and OmniClass and UniClass and all these other standards that have arisen to solve specific technical challenges and communication of data through the life cycle of the building. And these haven't necessarily been designed for the kind of data-driven analysis, the data-driven applications that we want to be able to author. And so the goal here, and what a lot of the tooling that we're working on nowadays, is how do we foster the representation of a brick model of that building, while preserving the value of those existing investments. We're not trying to replace the technologies that people have already invested time and money and expertise in, but we're trying to leverage those representations to unlock the potential of the building data. And so this brings us to Brick. Brick was authored in 2015 by a collection of researchers from several universities around the world, as well as a couple industrial labs. And what it is a graph-based metadata schema for smart buildings. Describing and providing the context for the physical, logical, and virtual entities in the buildings. Those are contextualized and defined, and their properties are indicated by the class organization that Brick defines. And the graph structure is assembled through these semantic relationships that tell us how different entities how different entities within the building relate to one another. And ultimately, this graph will allow Brick to describe the time series data that's being pulled out of the building, describe the data sinks and command points that govern how that building operates, and do so in a way that allows those applications to be written. So Brick is built on 3 main classes. The story today is a little more complex, but we'll focus on the main 3. We have points, which are any source of cyber-physical data that's in the building. Again, not limited to the BMS, but different kinds of sensors, different kinds of set points, commands, alarms, different parameters that govern how the BMS operates. We have the equipment, which are the physical assets in the building that span not just HVAC and lighting, but also electrical metering and water transportation, security and fire safety. So this is a constantly expanding array of classes that many of which the community has directly informed and directly contributed to. And there's also locations, which comprises not just physical locations like buildings and floors and rooms, but also logical locations like HVAC zones and lighting zones and fire zones. So again, a very rich set of classes that cover a large number of the use cases within buildings. And those instances of those classes are tied together with a set of relationships. And those relationships is they convey elements like the association of data with some context. So the is pointer relationship will associate your data source with the equipment that it's about or the location it's about. The feeds relationship denotes the topology of the system and shows us in what order equipment are connected or which equipment are connected to one another in order to deliver conditioned air or to remove exhaust return water out of a chiller system. Has part denotes composition, which locations are made up of other locations, which equipment are made up of other locations. Sorry, equipment are made up of other equipment. And then lastly, has location, which tells us roughly where things are located. And to sort of show how this looks, what this looks like inside a simple classic brick example building, you have nodes in your graph that represent the actual things that are there, the entities. The types of each of these entities are indicated by the association with a brick class. So we're not relying upon the label, the name of the entities that tell us what these things are. There is a relation to a class definition. And then lastly, there are the relationships that show how that actual building system is put together. So here we've got the air handling unit feeding into 2 VAVs, one into a zone that contains a couple of rooms, and then we have a damper and a collection of sensors and set points that tell us how that VAV might be operating. And the way this is going to fit into the way that applications are written, the way that data-driven software is written, is that Brick model becomes a digital representation of the assets and data sources inside a building. It lets us know how that building subsystems are assembled. And that digital representation of the building can be leveraged by applications written in arbitrary programming languages, not limited to Python here, where the application can then ask questions about the building by using the standardized digital representation to sort of abstract away all the difficulties of having to figure out which BMS you're talking to, what are the subsystems that are there, what's the API. It all gets lifted up to a common semantically enhanced layer that the application can access. And then once we have that brick model, the points, the data sources inside that brick model can be related and point to the data streams themselves, the historical data itself that is stored in a logically separate database, probably InfluxDB or TimescaleDB or Cassandra or whatever your favorite time series database is. And so this connection between the Brick model and the time series database is something that we've been focusing on more and more in recent months, making sure that we have a standard for attaching units of measure to Brick classes, making sure that we can standardize how to indicate the time series identifier for a particular point, so that there is some unity and standardization in how one interacts with the Brick model and its database, while being somewhat agnostic to how that is specifically implemented. And so to give you a taste of what this might look like for a slightly more complex and real building than the sample I showed before, here's the sort of classic, HVAC system like you might find in a large commercial building in the United States. We have the air handling unit in blue on the left, a couple of VAV boxes feeding into a set of rooms on a single floor, where HVAC zones contain multiple rooms, and some of those rooms contain one or more lighting zones. And then you have the return path back into the air handling unit. And what this looks like in Brick is some graph that look, something like that. To zoom in a little bit so you don't have to strain your eyes, this is what part of that location model might look like. The colored nodes here are the Brick classes, and the solid nodes, the outlined nodes, are the actual entities in the graph. So you can see the site is made up of a building, made up of a floor. The different rooms and zones then sort of compose with each other naturally. This is what a VAV might look like. You can see the dampers and the points associated with each of the components of that VAV, and then an air handling unit here, which contains a bit more complexity, a bit more components, but each of these have a relatively obvious Brick class associated with them. Okay, so what does it look like to query a Brick model? Sort of give you a quick taste here as well. So here's a sort of somewhat abbreviated Brick model on the left that shows supply airflow sensors associated with the VAV, and we have some of the building topology associated with that. And if we're trying to write a query that's going to allow us to calculate whether or not a given zone is meeting minimum airflow requirements, we might want to retrieve the identifier of the time series stream for the supply airflow sensor. We also want to get the volume of the room, and then of course we want to get the unit of what that volume of the room is. So there's a subset of the query that will traverse part of that graph, find any terminal unit, the downstream HVAC zone. We'll use the time series reference here to point to find out what the name of the data stream is that we need to pull out of our database. And then now Brick is able to express certain static quantities about the building, such as volume, and so we can retrieve that as well. And this kind of query more or less should work on many different kinds of buildings, because it has standardized what that graph should look like. And there's a few things that we can do that make this query a little bit more complex, that will allow it to run on a larger number of buildings, but this does get the idea across. Another feature that we've been working on in Brick and doing a better job of building some tooling for is validation. So now it's possible to define user-defined templates that allow us to validate the Brick model. So in a particular building, if we know what is in that building, we know what models or makes our equipment is, we might define a template that says all of the VAVs in this building for model XYZ must have this sensor in this set point, and they must contain a damper, and that damper should have a damper position command point associated with that. And if your graph matches the template that you have laid out, then you get the check mark. And if your graph does not meet the minimum requirements that are set forth in that template, then using standard semantic web tools and these templates, you can get a nice little report that tells you, oh, your damper is missing the data stream that should be associated with it. And it's our hope that these types of templates and validation can bring more regularity. Certain idioms to Brick models can make sure that people are entering Brick models correctly, using the Brick ontology in a correct manner. And we have some documentation about this feature on our website as well. And so to finish up this sort of quick, little overview of Brick, I just want to indicate a few things. First off, we have a new in development but still useful developer-focused documentation site at docs.brickschema.org. We have the concept documentation hosted on the website as always that includes the textual human readable definitions of each of the Brick classes. As always, we have our Brick examples and the TTL file itself available for download on the Brick Schema website. And we also have been working on a Python library which facilitates the use of Brick, the management of Brick models, graphs, and provides very easy use of some of these advanced features such as validation and inference, and I'll dig into that in a moment. But I guess really quickly, I'll pause if are there any questions about this overview before I go into a little bit more detail. Okay, wonderful. All right. So what I'm going to do in this presentation is give you a quick, and for all of these things, I could definitely go on for a couple hours on each of these topics, but this is why I say quick. So we'll go over the Brick implementation, show you how the Brick distribution is defined, how Brick can be extended, and then give a little taste of some of the tooling that is supported by the Brick Schema Python package and some of the work that we've been doing on facilitating the creation of Brick models. So we've been talking about Brick as a graph. The representation of that graph is through a W3 standard called RDF. RDF represents a directed labeled graph using triples. And so you can see the graph there on the bottom using the same color scheme as before. And you can see the three triples that define that graph. The object here, so thermostat and temperature sensor are Brick classes. Those are the object of the type relationship that tells you that a thermostat, tstat ABC is a thermostat, sen1 is a temperature sensor, and that the sen1 temperature sensor is associated with that thermostat. So if we then dig into the Brick turtle file, so turtle is one of the textual serialization formats of that RDF graph. What that class is going to contain is going to contain the declaration that the temperature sensor is a class. It's going to be related to other parts of the hierarchy. So a temperature sensor is a kind of sensor. That intersection of stuff is going to essentially automatically apply annotation tags onto any of your entities. Each of the Brick classes comes with a textual definition that's pulled from an ASHRAE dictionary or some other source. It has a set of associated tags, so this allows you to use tags to discover Brick classes as well as use tags to discover Brick entities. And this whole class definition together, there's over 700 of these defined within the Brick ontology, and it is designed to be extended. But of course, this is we would not want everyone to have to write all of this stuff themselves. And so what Brick comes with is not just the TTL file, but it comes with this whole Python-based framework that enables that simplifies the task of defining new classes, defining new properties, extending Brick, and you can find all of this on GitHub. And I encourage you to check this out after the presentation. So if we want to extend Brick, if we say, I guess I thought I had a slide before that. I think it probably comes later. Okay, so inside the Brick definition, inside the Brick source folder, there's a set of files that define different different parts of the Brick ontology. So this is the part of the file that defines sensors. So you can see we've got, so this sensor key here in the Python dictionary indicates the definition of the Brick sensor class. There's a list of the tags that are associated with it, and then we have another nested key value structure that lists the subclasses of the Brick sensor class. And so you can see here's temperature sensor is a subclass of that, air temperature sensor is a subclass of temperature sensor, and so on. And so given the structure, if we want to add something new, say a glycol temperature sensor, there's a few simple steps that we have to follow, and I'll walk through those now. So first, we have to find an appropriate parent class. What is the part of the existing Brick hierarchy that we would like to hang our new class off of? And for glycol temperature sensor, it seems natural that the temperature sensor class should be the parent there. And so we can simply insert our class definition there. So we can add our tags. We add the substances here. That's sort of additional annotations that can be used by documentation and automated tooling. A bit beyond the scope of this talk, but if anyone's curious, I can speak a little bit more about that. Now that that class is defined, we go into the definitions.csv file that's provided also within the Brick source code, and we can add a line here to that file which says, here's the definition. I put something simple here. Here's the definition of that new class. Now that we've added the definitions, there's a make file that's provided that goes through all of the definitions. It compiles all of that source code into a brick.ttl file. And then we've created a set of integration tests and unit tests that verify that your definition is not causing any circular class definitions. It's not violating any sort of logical consistency checks. And so if you pass the unit tests, there's a good chance that you did the extension correctly. And all of this is documented in detail in our contributing document that's also within the repository. It lets you know how to set up the development environment, how to run the tests, different conventions for class naming, and how to go about Brick development. And if there's anything missing there, definitely file an issue and let us know. Okay, so now you're now all experts on how to extend the Brick note on how to, sorry, there's an odd sound. I'll give you a quick note on how to use some of the Brick tooling. So we defined a Python package called Brick Schema, which simplifies a lot of the tasks that we were writing over and over again when we were using Brick. So in order to use the graph is the unit of management for Brick. So we want to create a new graph. We can put triples in there, and that represents our building or represents our campus or whatever it needs to do. So we can create an empty graph. We can create a new a graph that has a recent version of Brick already loaded into it. We can ask our library to download the absolute latest version of Brick from the Brick website, or we can even create a Brick model from an existing metadata representation. So we have an import function that takes as an argument a JSON export of a haystack model, and it will do its best to create a Brick model from that. Once that graph exists, we can now load in the stuff that we actually care about, load in the actual building definition file. This can either be stored as a file on disk, it can be retrieved out of a database, it can be retrieved from a URL, from maybe some internal file share that you have, and this also loads the triples in that file into the graph object in memory. So Reasoning and inference is definitely beyond the scope of this presentation, but you can think of it as essentially as a quote compilation step for your graph, where it uses the axioms and rules defined within the Brick ontology to add information that is implied by the other statements that you made. Before, this is usually involves invoking a separate piece of software. It usually involves a bunch of sort of complex configuration, and what we've done in this library is abstracted all of that behind a simple expand call. And so we can invoke the OWL profile or the OWL and a shackle profile, whatever sort of combination of reasoning rules we want to be able to run. By and large, it's good to just run OWL and shackle. And there's documentation on the website that points out what reasoning does, why it's a good idea to do it, and we've tried as much as possible to make this easy to use. There's also validation supported by the Brick Schema library. So once you have your building file, you have your graph with everything loaded into it, you can just call the validate method. You get a Boolean flag and a little report, and if that flag is false, then you can print out that report, and you get the a piece of a little text readout of which entities in your graph are missing which properties, why they failed validation, and so on. And that information can be used to rectify the definition of the graph. The Brick Schema library also contains a number of extensions. So we've defined some more advanced features like inferring brick classes from brick tags, which is something we talked about in a paper we published in 2019 in the BuildSys conference. And so that is an optional feature that you can load in and run that yourself if that's something you want to be able to do. We've also defined a growing set of alignments with other ontologies, other metadata systems, including today, but this is not the final set, but VBIS, Real Estate Core, Building Topology Ontology. And so if you want to import into your graph the set of rules that define how Brick's concepts align with or relate to concepts defined in another standard, you can load that in pretty easily and infer whatever the bot classes are, the real estate core classes are that you would need to make your graph compatible with those standards. And then lastly, of course, you can also run queries on this. So we can run a query that allows us to, get the sensors and set points for airflow, so we can tell if there are any rogue zones in the building. It just gives you that as an iterator, so you can loop through and put that into a data frame or join it with your time series database, whatever you need to do. Also, conveniently, there's a little built-in web server. So if you have your graph, you call .serve, then you get a little browser window that allows you to run Sparkle queries against your graph, visualize the results, and even apply reasoning just by clicking a button. All right, and so I'll finish up with an overview of Brick Builder. So you'll recall that one of the most common sources of building metadata are these unstructured or semi-structured labels that you get out of your building management system. And so what we wanted to do was make it easy to try and parse out the structure of those to facilitate the inclusion into a brick model. And so we built on top of OpenRefine, which is a project from Google. You can think of it as though it's now independently maintained, you can think of it as a sort of supercharged web-based Excel that you can just run on your computer. And it allows you to split up these labels, group them by similarity, slice them and dice them however you want. What you can see on the right-hand column there is a inference technique. So if you have part of that label that indicates the type of something, the type of what something is, you can send that to an external service that will do its best to infer which brick class is meant by that. And so you can see some of these here are matched up and some of them aren't. And we're in the process of developing new and more robust tools for doing this automatically. But essentially, once you have that OpenRefine workflow down and you've imported your building management labels, you've parsed them out, you can then export those subsets of those as CSV files, and you can write this template that says, essentially tells the program how to interpret the rows and columns of that CSV file as parts of a graph. And so in this example, this would generate these little subgraphs from each row of that CSV file that define the name of a VAV, the names of its associated sensors and set points, and plus a Boolean flag if that VAV has reheat capability. Yeah, so there is a tutorial video that I put together that shows how that whole workflow works. There's more advanced tooling along these lines coming soon, so definitely keep an eye out for future developments. And that's all I have. Any questions on that?
Okay, well, thanks, Gabe. I'm going to take control back over here. And so we started down here at the bottom of how it is that we're developing Brick and what goes into the code of the Brick releases and the Brick tools. And so I'm going to walk up a little bit how are we actually organizing the people to do this. And how it's been happening right now is there's been an ad hoc crew of developers who work on this, and again, the mailing list. And they've been sort of working on all parts of this. And as we are starting to grow this group, we're going to reorganize ourselves just a little bit into a set of working groups. And so I'm going to jump right into the working groups here. And we've got four working groups that we think we're going to spin up, two of which are pretty familiar, two more of which are maybe a little newer to the group, so we're going to present all of them here. And the first group is what we're calling the Schema working group. And this is what most people are thinking about when we talk about developing Brick. And this is the group that is going to be responsible for managing the Brick schema, so what classes, what relationships go into the version 1.3 of the schema. How do we actually code that up and develop that? What's the right way to do that modeling? So we're working on how are we modeling properties? What's the right approach to consider that as a construct? And then now, once we figured out sort of how do we actually want to model properties, which properties do we want to model? And this is going to be the group that works on that. And the working groups it's an open source project that mostly works asynchronous, so it will continue to mostly work through GitHub issues and pull requests and the mailing lists. But it will also have probably a weekly or bi-weekly call to have a synchronous checkpoint, just to maybe accelerate a few discussions and to think about things. We'll have to figure it out. Synchronous calls are tough because of people's schedules and time zones, and we don't want anyone left out just because they can't make the call. But it will be a group of folks who are more concerned on developing the schema, and the schema working group is going to be charged with that. The second working group that we have in mind is the tooling working group, and this is more of a software development project than the schema modeling group, and it's charged with producing the tools that make it easier to create, manage, and exchange brick models. So things that are sort of in its wheelhouse, the Pi brick schema package, the brick builder tool, and the cool next gen version that we hope that CMU is going to be able to get out soon. There was a paper at the BuildSys conference with a paper over the system from UC Berkeley and Lawrence Berkeley National Labs and a few other folks that was about managing building data as it moves through the building life cycle and pulling it in from all these different sources, IFCs and GVXMLs and what have you. And so that tool exists, and it's in it's open source. It's in rough research prototype stage, and so can that get hardened up, and can this working group work on that and other tools that are useful to the community that the working group members want to contribute or want to create as part of a working group. And so this is, again, will also work like as an open source project. GitHub issues mailing this, probably have a synchronous call to excuse me, to keep things moving along when sometimes a synchronous call would be helpful. The third working group is not one that we focused on a lot in Brick, but one that we want to get going a little bit more, which is an applications working group. And in the beginning, this will probably be more sort of an analytics working group than an applications working group, but we'll sort of see. But this is the folks that we want to think about how do you actually apply Brick. So we have this open source schema that you can apply to a building, and it can bring these third-party applications to it. Well, let's make sure that there are some third-party applications that are out there and can use this Brick data. This is actually really important for the schema working group because we need to be sure that we're always validating the Brick schema. So we get the best feedback from people who are using Brick and finding its shortcomings of, hey, I tried to do this and I couldn't figure out how to do it. How do we do this? And so we want to bring some of that, hey, I'm using Brick and how do I do this into the consortium and in-house, so we have this validation, kind of check and balance on the schema to make sure that we're making something that people want to use. And that's what the application group is going to do. And as well as there's a lot of great algorithms and ideas and analytics that are out there. Let's make sure that we translate those into Brick so that they can be more widely distributed. So this group is going to work closely with the other working groups, especially the schema working group, somewhat with the tooling working group, to give them feedback. And we think that the application working group may have some overlap with the schema working group for creating reference models. So an important question is, how do I actually use Brick and how do I apply Brick in this use case? And a couple of sample buildings with good documentation for here's how we modeled this building with these characteristics in Brick is a very instructive for people who are picking up and trying to use Brick to model their own building. And we think this working group will do some of that as well. The fourth working group is what we're calling our data sets working group. And there's a lot of interest in collecting data sets of example buildings. This is important to the research community to be out there to have data to apply, so the research community can have data to apply their algorithms against. This is important for software developers to have a test bed to test against. There's a lot, I don't know there's a lot, but there are multiple efforts out there that are also doing something like this. We think this working group will work closely with them. Maybe this working group will dissolve itself and simply jump over and work on one of those things. Maybe those other things will join with this. We don't really know, but we know that there is demand and need for example data sets for the built environment, and we want to do our part in helping to create those. We think this working group will work very closely with our tooling working group. We think that potentially some of the serving infrastructure, if it turns out that the way to do this is to create a serving infrastructure to serve up these anonymous data sets, we think that same platform might be useful not for serving public anonymized data, but for serving data for an organization internally. And so this that'll be in the scope of this working group to consider is there serving infrastructure that and other tooling that's useful. Model ingestion and model creation tools for that are also very useful. This group needs these steps often will need an anonymization step, but if you can drop that and still have those same tools for your local organization, those tools are also useful there. So that's kind of our fourth. The first two are pretty familiar to the Brick community. Second two, we think that there's interest and demand out there, and so we're interested in spinning those up. So that is the working groups, and some next steps on that. We think these groups will kick off here later in the month. There's a survey to try and help us schedule to have kind of first kickoff meetings for all of them. If you haven't added your name, someone will drop this into the chat, so you don't have to try and screenshot this or type in, a Google random string of characters to find this. It's also on the Brick Schema mailing list. We're just trying to put together some times. Again, we know that not everyone will all be able to make same synchronous time, so all these things will work asynchronously via email and GitHub and so on. But if we can have a virtual kickoff for the working groups, that's our goal. We think that somewhere in the horizon there's probably going to be 2 more working groups. We're not really sure on the timing. Some kind of test bed for Brick. The BACnet testing labs is actually sort of our inspiration of where could we eventually go. A way to say this, if your product says it's Brick compatible, we'd like to be able to have a standard set of tests so that it can run to say that it is in fact Brick compatible. And sort of related to that is a data exchange. What's the format? What's the profile? How would Brick data be exchanged between these various profiles? We think that will also be an important step in making Brick more widely useful. And so we're not sure on the timing of this, but sometime in the future. Again, we hope to get the working groups kicked off in March. We've got, but there's still time to get your schedule availability in, because we haven't actually tried to schedule the first set of working group meetings for these 4. So now I want to talk a little bit about the Brick Consortium. And so we started at the bottom of the organization structure at the working groups. I'm just going to work my way back up to explain the rest of it. First off, I'm just going to say that the Brick Consortium is a bigger organization than we need right now. Right now, we have sort of a working group or 2 and maybe a technical committee, maybe one of the committees worth of people that have been ongoing. So this is, in some sense, more than we need, but that's okay. The parts that we don't need that much, we won't use that much, and we will grow into this full structure. So down at the bottom, the working groups, I left the 4th one off because of space. Each of the working groups is the day-to-day. This is where things are happening. All of the working groups are overseen by a committee that's called the Technical Committee. And the Technical Committee is responsible for overseeing the working groups, creating the working groups. The Technical Committee will work on the working groups. Everyone on the Technical Committee is going to be part of the working group. The main function of the Technical Committee, its formal responsibility, is to send the Brick schema out for approval. And I sort of skipped over this slide earlier, but Brick 1.2 came out when the Brick developers sort of deemed it done. And how we envision 1.3 coming out is that we'll continue to develop Brick 1.3 through the open source process, just like we do today. But at some point, the ontology group will say, we think we're about done. The technical committee will take a look and we'll decide, yes, we agree, and they will have a vote to send the schema out to all of the Brick members for approval. And all membership, or all organizations with membership are eligible to vote on this. And then there's a clock that starts ticking down to get everyone to vote on the approval. Is this ready to go out as Brick 1.3? This is in line with a lot of other standards committees, OASIS, I think WZ3, a bunch of things work this way, where development happens day to day, and once we reach a point of being sort of ready to go, the standard gets voted on. And so that's most of what the technical committee does, and then a lot of coordination. So, and can we help the committees work together, make sure that everyone's communicating, and so on. There are The technical committee is overseen by a steering committee. This is responsible for the day-to-day sort of things. There's some IP roles for this. We'll talk about that in just a second. The steering committee sets the rules for the organization. It sets the membership fees. It's not going to do a whole lot in 2021. Perhaps someday when the organization's bigger, it will have more to do. But for now, it's pretty minimal oversight. And then there is a board of directors, which is only for corporate governance. It did the initial approval of the membership rules. It files the taxes and reports to the state government to prove that we're a real corporation, and it's won't meet all that frequency, so we won't go into it. There are two other committees that the membership agreement lays out as committees. They're going to mostly be on hold for the beginning as we get going. There's a technical service committee that was envisioned as the conformance test. We're not ready to go on that, so that'll say it's sort of in hibernation for a while. And there's a communications committee that will take over the Brick website and do public relations and PR events. It would do things like this event, participation at the AHR show, Realcomm, pick your favorite events. That working group would get the word out about Brick and help people know and use Brick. For now, we'll sort of just handle that through the technical committee and the steering committee, but we definitely see this coming to life in the future, especially as we emerge from COVID and events start actually happening in person and we start doing things and meeting back together again. So again, we'll grow into this. It's kind of a weird thing to say, but I always think of us as like, a crab or an insect that's got a shell that we're not quite ready to need all of, but someday we'll have it and fill into that. So just a word about IP. I mentioned that the steering committee has some IP rules. We'll just say, I don't want to belabor this, but we take IP and IP disclosure very seriously. And this isn't because we're going to try and demand everyone's IP and you have to sign over the rights to everything you've ever done and your firstborn to participate in Brick. But what we really want to make sure that we have is that no one is surprised, that everyone who participates in this, no one is surprised by any IP claims that come out after the standard. What we don't want is to have some standard that you can't use without having to license a whole bunch of IP that you didn't know about before before adopting the standard. So there are strict requirements about disclosing IP. So Brick doesn't rule it out. It doesn't say that there can't ever be any IP, but it all has to be disclosed. We don't want anyone to be surprised. So there's requirements on you to say if you're participating, if you propose something, and if you have IP around it, you have to disclose that when you propose it. There's also requirements even around if you are aware of something that's about to go into the standard, even if you don't own it, you should disclose it so everyone is aware of it going into it. And again, if it doesn't rule it out, the steering committee can potentially say, yes, we can include it because we've worked out with the owner on what the right deals is and how it will all work. But by and large, you can sort of assume that if there's IP in there, it's disclosed and everyone knows it. Now, it's a schema, it's a standard. There's probably not a lot of IP in that, but we don't want anyone to be surprised. And we want everyone to be disclosed about. So we took inspiration from the IETF, which has similar rules. Ours go a little bit farther in closing some loopholes around ways that IP could get in without some disclosures. And so we've tried to block that all off. I just want to say that I'm not a lawyer, and so please read Section 5 of the membership rules and go by what it says. That's a whole lot of lawyers from universities and corporations have taken a look at that and have kind of come to consensus that this is something that will work for most organizations. So please take a look at that and go by what you read in that and not what you read on my slide, because the membership rules are the canonical versions of that. So, okay, enough with the legalese. To join the consortium, it's pretty straightforward. There's a membership form on the Brick website under brickschema.org/consortium, along with the membership rules. The form just says, I read the membership rules and I agree to them. So then you just need to pick the appropriate membership level. Full commercial members can do everything. Contributing members for commercial, you do almost everything except for voting for the steering committee. Institutional members and academic researchers can do all these things, but they don't have to pay. But it's just chairing committees, it's serving on all the committees, it's voting on the committees, and of course, it's all open source. And so, should you not wish to join, you can still contribute and you can still participate in the open source thing. You just don't get a vote in the organization. And there'll probably be other things that the consortium does for consortium members with regards to trainings and some collateral to help with maybe project proposals. So when you're responding to RFPs, there may be some material that we provide to members to help them make it more likely that they'll succeed if there's a requirement for Brick in that. So it's a membership-driven organization, and we'll figure out what the membership wants from the full consortium as we spin things up. So now we're coming into the last part of the session here, and I'm going to switch over to our Brick roadmap in just a second. But kind of how we envision this last part to work would be around a discussion around sort of three questions. First of all, I'll tell you some of the things that we're thinking about doing for Brick 1.3 and beyond, but we're very interested in hearing from other folks around these questions. So if you're a potential adopter of Brick, we'd love to know, what do you think is important to see in Brick? And if you're a potential adopter of Brick and you make a product, what's necessary for Brick to see for you to get Brick into your product? And we're very interested in, what are you willing to work on? So is there something you want to see in the schema, and are you willing to work on the group to help us define that? Is there a tool you want, and are you able to help us develop that, or do you have some code to do that? Is there a new domain for Brick that, what we need to get Brick into the AV equipment, or do better in lighting or something in that domain? So we're very interested in knowing what domains, what code, what are you able and willing to help us work on. So you don't have to tell us today if you want to think about it some, and having speaking out in a big group meeting is not the right setting. We'd love to hear from you via email after the event too. So please don't feel like you have to answer these questions today, but we really do want, your feedback on this or any other feedback that you've got. So again, what do you think is important to see in Brick? What's necessary for you to get Brick into your products, and what are you willing to work on? And I'm going to go to our Brick schema roadmap, which is also, it's just redirects to GitHub. So hang on just one second while I switch windows. And where'd it go? Here we are. All right, so this is the GitHub public roadmap, and the way we've organized this is we're looking sort of 4 chunks in time. We're looking, hopefully you can see my cursor here. So on the far left hand, we've got what's coming up in our next release. This is the patch release for 1.2.1. This is something we'll do in the next couple of weeks. And these are sort of short-term things. These are some classes that Carlos suggested that, hey, you could use in that. These are just extending existing type hierarchies, and so that can go in. It's not a big change. So these sort of short-term things. We're looking to do another release of Brick. We're aiming for sort of 2 big releases a year, a winter release and a summer release, and we'll do a 1.3 sometime in June or July or sometime when it's a lot warmer. And we're thinking ahead for what do we want to have in that. And we've got a couple ideas for that. Kind of the big ones are this points about points. So metadata about points. So if I've got some sensor, what are the thresholds for this sensor? This is maybe static data about the point that doesn't change that often that we want to express it, or maybe it is some kind of configurable thing about that. So we want to be able to have these additional metadata about points. We think that having the network being able to represent the BMS network is probably useful. Maybe that should be in BACnet, maybe that should be in Brick. We're not sure yet, but we think that there'll be something for us to do. Schedules we think are important, and we are starting to just think about that. Similar with weather. We've been working on doing some chiller plant modeling. We've got that was going to be a 1.2, but we've kicked it out a little bit, and so on. So we've got some ideas for what we're going to think about for our June release. We've got other ideas that we're calling kind of long term. This might come into 1.3. This might be 1.4. This might be 1.5 or beyond. We're not really sure when we're going to do some of these things, but these are longer term things that we may not know yet about, or we might not. We might not think it's super urgent just yet to tackle. And then we have a 4th category of things we want to do, but we can't do for some other reason. There's a bunch of stuff coming in Haystack 4 that we'd like to take advantage of. The Haystack 4 spec has to finish before we can take that on. So this is how we've been thinking about things for now, but we are open to have a discussion about other things. And we just generally would love feedback on well, anything and everything, but particularly around how to join and what you'd like to work on if you were to join the consortium, or any of the questions you've had on anything. So I'm just going to kind of open it up to the for a wider discussion, and anything goes. The floor is sort of open, and we're happy to answer questions or take feedback. You probably have to unmute yourself. Teams is pretty good about muting you. So if you've got questions, go ahead and give a shout out or drop them into chat, or however you want to do it. And if you don't have questions, we're not going to make everyone stand around for 30 minutes waiting. So don't feel too bad if you don't have anything to chime in here right now. So.
So there's a question in the chat. As someone from a design commissioning background, my reaction is, 1, this is awesome and badly needed, and 2, how in the heck is the average building engineer going to navigate this? This is an excellent question, because we definitely don't want to be in the position of trying to teach everyone in the world semantic web and Sparkle and RDF and the graph and all the rest of this stuff. So I think what's important about Brick is that it provides a standard basis on which higher level tools and more intuitive interfaces can be built, so that the metadata that's derived from those maybe more intuitive user experiences can always be linked back to the same standard. So you're still talking about the same things. Um, and I think it's a very interesting question what the proper way of exposing this information is to the end user. This is the kind of stuff that's maybe more familiar to a software engineer than it is to a building manager or a building engineer. So we are very open to ideas that people have, existing interfaces that you would like to support Brick. You know, wild, crazy out there ideas of what that interface might look like. But it's something we're definitely actively investigating.
Yeah, I think I just echo that. The semantic web stuff is scary, but also um, uh, can sort of disappear for most people. It turns out the semantic web got got a rep as being really scary, but millions of webmasters use it every day with Google because of the schema.org markup for search engine better results. It's all based on semantic web. So I think it can be taught, but it definitely is um, a challenge that you can't just throw a Sparkle book at them and say, "Hope you remembered your first order logic from sophomore philosophy class in order to make this work." So another question from Brent: are any of the major BMS manufacturers involved in developing or planning to adopt Brick? Um, there are some. Certainly, Johnson Controls is involved. I can't actually speak about in the lawyers are kind of want us to be like Apple. We don't talk about future products, and so I can't say exactly how we're going to use Brick, um, but it's something it's important to JCI, and we hope to get others involved as well. Some of this will come in through ASHRAE 223P, which is similar to Brick, so there'll be some interoperability through that where other building manufacturers will come in as well. Another question, are any building product manufacturers getting involved? I guess I wanted to clarify what we mean by building product manufacturers. Some we've talked to a couple of folks who make contraptions that aren't traditional building management systems. So it's not a BMS, but it is equipment that goes into commercial buildings. They're not on the call right now, so I can't really talk about what their plans are. But there are things that you have in your building that you would not have anticipated, that you would not associate with a traditional BMS is one way to put it. And we hope to get some lighting folks involved. We hope to get some of the as we start defining out some of the ways to represent Brick and exchange Brick to systems for a plug and play sort of compatibility mode. I think there's some interest there. So we're hopeful. And if that wasn't what you meant by building product manufacturers, please just point me in the right direction, or we can take it offline if you'd rather. I'll say if you are currently producing building products, we'd love to have you on board. So if you make occupancy sensors, we'd love to talk to you about how to mark up your products with Brick classes for your occupancy sensors or whatever your product is.
One thing that I'll note on that subject is that one of the elements that the ASHRAE working group has been working on is a way of representing RDF data inside BACnet objects. So this is something that Joel Bender from Cornell and the author of the Backpipes library has been working on. And so once it's possible to represent RDF data inside a BACnet object, and that can represent Brick, that can hold 223, that can hold other ontologies. So there is both the sort of standardization effort and, things like 223 and Brick, as those come off the ground, hopefully people start to include them. But there's also the technical mechanism by which that will be able to be included. And hopefully someday when you scrape your BACnet network, you can come with some Brick annotations or some 223 annotations with it.
Also, feel free to unmute yourself and ask your question that way, or chat, whichever. Well, if if no one else has any more questions or anything, just a couple of wrap-up thoughts. First off, we'll get the links out to anyone who wanted it signed up for that. Slides and video recording. We're ready to have folks join the consortium. So if you're interested in joining, we're ready to process that. Just drop me a note and we can get you going. Other than that, thanks to Gabe for participating and giving his part of the presentation. And thank you all very much for joining us tonight or this morning, depending on where you are. And we look forward to hearing from you in the project down the road. So we'll stick around for a while if anyone's got any other questions. But other than that, thank you so much. And we'll hear from you soon.